In this video, I'm going to measure the cutoff voltages, both the lower and upper, of this Wagan 400 watt pure sine wave inverter. So now I'm going to enable the voltage on the power supply output, and then I'm going to turn on the inverter and give it a second to turn on the AC. We can see it hasn't yet. Okay, now we can see the AC is coming on here, and we have the AC coming out here. And in a second, this will finish initializing, and we'll see what the voltage output is. There we go. So with 14 volts on the power supply and 14 volts to the input of the inverter, again, this is hooked up to measure the voltage exactly going into the inverter in case there's any voltage drop along these wires. We've got 113 volts on the AC out. So let's go ahead and turn that down and see what happens. We'll go down to 13, and we see this went down a little bit to about 112, maybe 113. And we'll go down to 12 volts. And this stayed pretty consistent on the voltage. That's good. And we'll go down to 11. And now we do see a drop here compared to the other one. So that's interesting. So now we're going to go ahead and slowly go down and see where the inverter kicks off. And these two voltages have been pretty much aligned because there is no load. All right, so 10.6, we start to hear the beeping, and I bet you it's going to kick off here probably at the same 10 volts even. 10.2. There. Basically 10.2 was the minimum that this was going to take. So let's go ahead and reset it. 14. This is going to turn on. There we go. We skipped the initialization. And let's see what the upper range is. Again, with no load. 15 volts. So we'll go up slowly. So about 15.5 max input is what this one will take compared to 16 volts on the other unit. And if we go back down, it automatically resets. So let's see what happens when this turns off. What's the voltage required in order for it to turn on again? Because it isn't usually just like 0.1 volts up. So we'll get it to turn off. Go down to 10, kicked off. Now let's slowly go up and see at what voltage it'll kick on again. Looks like 12.6, 12.7 volts. The unit will then kick on again and start providing AC. All right. Now let's repeat those tests with an actual load. We're going to again use my 75 watt light bulb, and we can hear, maybe you can hear a faint background. This one has a fan running because it's much smaller. It needs to stay cool. So we've got 14 volts here. We've got 13.87 volts there. Let's go down and find out what the cutoff is if it stays the same. We were around 11 volts previously, so let's take a look at that. We can see this voltage is actually staying pretty consistent with the load, actually a little bit higher than before too. So let's go down to 11. Now it's about the same, 112 volts. Now, and then here we're seeing 10.85. I'm sure it's going to be right around the same, 10.5. Yep, and if you boost up a little bit, still beeps. Probably have to go way up. Yeah, anyway, let's find out what the cutoff is. 10.4. 10.3, I'm looking at that one. 10.25, 10.16. That was the cutoff there. So we'll go back up to 14. This kicks on, skip the initialization. Let's see what the upper range with the load is. 15 volts, 14.9 on the voltmeter. Interesting, the output's 110 volts, so it went down a little bit. 109 volts, 108. That's interesting, it's inverted. The higher the voltage, the lower your AC output with the load. 15.5, I think this was where we were cutting off before. And there it kicks off. It does not like that. So we will go back down to 14. And it automatically resets. That part's pretty nice. All right. I've created a little summary of what we've measured during this video on the Wagan Elite 400 watt pure sine wave inverter. For the no-load AC voltage test, we can see we run the range from about 109 volts to about 114, 115 volts. For the load test with the 75 watt incandescent light bulb, we can see the voltage actually changed. It started around 107, 108, went up to about 114, then went back down to about 108 when we had a higher input DC voltage. The alert behavior was a little different than the 1000 watt inverter I tested in the other video. Here we got the low voltage alert at about 10.6 volts, and the cutoff was a little higher at 10.1 volts. The interesting thing is the low voltage restart after cutoff was a bit higher at 12.7 volts. The high voltage alert, there basically wasn't any. It would just cut off, and that occurred at 15.6 volts. And the high voltage restart after cutoff was 15.0 volts. Now focusing on the bottom left, we can see the no-load current draw at 14 volts. We measured about 0.24 amps or 3.3 watts. That was significantly lower than the Wagan 1000 watt inverter, which basically was double at 0.47 amps or 6.6 watts. With the load, this inverter had 5.8 amp draw with 82 watts, which was slightly higher than the Wagan 1000 watt inverter, which had 5.3 or 74 watts. So with the load, we can see it's slightly less efficient than the larger inverter, but if there is no load, it's quite a bit more efficient. That wraps up the testing for this inverter. If you got something out of this video, please like and subscribe. And please consider watching one of my other videos which you can click on here. Hope you have a great day.